So we're gonna start a new chapter now, which is about algorithms, intro to algorithms. And it is an important chapter, especially when it comes to your major, right? IST. It's very important that you understand how algorithms work. And so we're gonna be spending some time on this chapter. I want to make sure that you're good with algorithms because programming is an essential part of your major, and uh, underlying any program there is an algorithm, and you should be good with algorithms. So we'll basically look at some simple algorithms today. So let's first define an algorithm. An algorithm is just step by step your strategy basically to solve a problem, right? And so in this chapter we're gonna be using pseudocode, but obviously since we have been using Python extensively, I'm gonna give you the option of writing the codes or the algorithms in Python also. But there is a language called it's called a pseudocode, which is basically something in between English and a computer language, right? And there's in an algorithm, there's going to be an assignment which you guys, I'm quite sure, are familiar with, right? When we write a program, there's usually a variable assignment, and then there is an output of the algorithm, which is called a return statement, right? So this is what constitutes an algorithm. Let's look at a simple algorithm, right? So we have two numbers over here, x and y. And so this is how the assignment works in the pseudocode with a colon. So again, if you use Python syntax, that's also fine. Now, if x is less than y, then minimum will be x, right? And max will be y. It's just figuring out the maximum of two numbers and the minimum of two numbers, right? So it's a simple algorithm. So else, if that's not the case, y would be the minimum number and x would be the max, right? So in this case, you get min as x. This the algorithm goes in and checks the condition. This condition is true, so it basically assigns minimum to x and max to y, and that's what these are the values that are returned. Okay, now in this algorithm, you're computing the smallest of three numbers, right? So now the way you write the input and output statements, so as I said, that it's the pseudocode is a language between computer language and English, right? So it's just the input is just the input statement is just basically plain English, where you say, okay, real numbers are the input, A, B, C are the input and the real numbers, and the output is going to be the minimum and the smallest value amongst these three numbers. So what you're going to do is the algorithm works the following way. You first set minimum to A, so you don't know whether that's a minimum or not, but then you basically go and check whether B is less than the minimum. If B is less than the minimum, you set minimum equal to B. If C is less than minimum, you set minimum equal to C, and then you return the minimum. And so the output of the program returns 5. So if you enter a 759, if you choose 759 for the numbers, then the minimum is 5. And you can see that for these numbers, minimum would be 7, right? So you first set it equal to 7, so min would be equal to 7, and then when you approach this if statement, so it would check that if 5 is less than 7, so that is true, so min would be equal to 5, right? So it changes the value of min. Now it would check if 9 is less than 7, which is false, so this is not executed, right? So then it returns 5 as the value. Okay. Now in these programs, these algorithms, right, you'll typically see quite a lot of these type of programs where you have nested loop for loops, right? So what I've noticed in my previous classes is that students get confused with nested for loops, how nested for loops work. So make sure you figure it out while I'm explaining it. So and we're gonna do it in a particular way. We're gonna draw tables and basically write down each iteration. That makes it easy. You don't have to do it that way, but this is just to make sure. So if you were getting confused, the table would make it relatively easier for you to figure out the output. So now in this case, you are starting with a variable count equals 0. You have two loops. So for I equals 1 to 2, for j equals 1 to 2. So this is the inner loop. So this one is the outer loop, and this is the inner loop. Okay, and when you go into the inner loop, you basically redefine count as j multiplied by count minus I, and then the inner loop ends, and then so this is the end of the inner loop, this is the end of the outer loop. So now how do we solve this? How do we figure out the final value of count? I want you to do it in this way, right? Again, you don't have to do it this way, but if you don't have any experience with nested for loops, definitely do it this way. But if you're good with for loops, that's fine. You can do it other ways that you are comfortable with. So now in the table we have a column for I, a column for j, and the column for the variable that is being updated. Right. So now let's see how this works. So you're starting with count equals 0, right? So this is your equation. So we have this equation, right? This right hand side over here. Okay, and so for each column, you have to read off what the values of I and j are, and then just plug them in and carry over the value of count for each case. So in this case, I is 1, j is 1, count is 0, right? So you have to plug in that. So j is 1, count is 0, and I is 1. So that gives you minus 1. This is 1 multiplied by minus 1. You get minus 1. Okay, let's write that down. So minus 1 is the value of count. That is going to go into the next row. So now so remember, when I is 1, so this is how the loop works. I is first 1, and then the inner loop is going to be executed with j equals 1 and then j equals 2. When this is done, it goes back to the outer loop and then sets I equal 2 and then comes back to the inner loop. So this is how the loops would work. And so so then you go to the next row and write I is still 1 because the inner loop is not done. J is going to be 2 now. So make sure you get this point because students would write the next value of I as 2. So don't do that. Finish the inner loop first and then go to the outer loop. So now this -1 is carried over here to the count, right? And then you can see that j is 2, right? J is 2, and then I is 1. So this is where you get the I. And then you solve this, that gives you -4. Now this -4 is carried over here. See, the count is just being carried over to the next row, and then you're replacing j with 1 and then with whatever the row has, and then I is 2, and figure out what this number is, right? And so the final value of count is therefore -16. So in total we have 2 multiplied by 2. This is outer loop and this is inner loop, right? So if let's say j is 3, then you get 6 iterations. Over here there are a total of 1, 2, 3, 4 iterations in the whole loop. Okay, so the worksheet for today is just handwritten, right? So just look at so whenever you go to the module section, you go in there. If there's a Python assignment, you have to do the Python assignment. If I post a PDF saying worksheet, you complete the worksheet only. If I have a worksheet and a Python assignment, you complete that. So it's just whatever is in the module section is your assignment for that day, and then you complete it and you post it. You submit it on the assignment section. Okay. So for today is just a written assignment, but we'll be doing a few Python programs, and that's going to be in the coming classes. Okay, have a good one.